All right, today's the fourth day. I'll be going over some important release questions from old SBAC tests and other concepts that are important for SBAC, day 4. All right, so we have enter the distance in units between point A and C. So here's point A and point C, and I just have to figure out how far apart they are. This one is at -2, so it's 2 this way. And this one is at +3, so it's 3 this way. So it's a total of 5 units apart, so 5 units. If I were asked how far B and C were apart, you would simply just figure out that there were 2 units between it, so it would be 2 units. Tony made a table that shows a relationship between the total number of apples and the number of boxes of apples. Each box has the same number of apples. Tony made an error in 1 row. Okay, so we see we have 15 apples in 2 boxes, 75 in 5 boxes, 105 in 7 boxes. So what we've got to do is figure out how many we're putting into each box. So if you look at this one, that kind of looks kind of hard because we have 15 divided by 2, which means in this case, they're putting 7.5 apples in each box. If we do 75 divided by 5, that means there's 15 in each box. 105 divided by 7. 105 divided by 7 should be 15 in each box, 15 in each box, 15 in each box. So obviously this is where he made the error. We should be putting 15 in each box. So this should be a 1. It says which row contains Tony's error? Well, and it says enter the row number in the first response box. So you would put row 1. And then it says what is the correct number of apples for the row you selected. So if what it's wanting me to correct is apples, and we have 2 boxes, then what we should have had here for number of apples is 30, because that would make it 15 in each box. So you should have had 15 apples. Will states there's no number greater than 0.59 or 59 hundredths that has a 5 in the tens place. Create a number that will show Will's statement is false. So we already have a 0. We know that we have to have a 5 in the tens place. Basically, as long as these aren't zeros, we've created a bigger number. So you could say 1, 1, 2, 9, whatever. As long as these numbers here were not zeros, then it would be a number that is bigger than 5/10. Julia needs to make a box in the shape of a rectangular prism with a height of 3 inches and a volume of 243 cubic inches. The dimensions in inches must be whole numbers greater than 1. Julia claims that the length and width of the box must be equal, length and width. So if I were to draw what she's referring to, we know that the volume, which is length times width times height, is 243. And I know up here it tells me that the height is 3, so this is 3 inches. So I know that this is 3. And I'm trying to figure out what is length and width if they're the same. So what I'm going to do is divide 243 divided by 3, and I'm going to get 81. So that means that these numbers need to multiply together to give me 81. And they're the same number. So what number times itself is 81? That's 9. So A, what dimensions would support Julia's claim about the length and width of the box? So it would be dimensions 9 times 3. Part B, length is 9, width is 9. B, length and width. What dimensions would not support Julia's claim about the length and width of the box? Enter your answer in the boxes labeled part B. So it would be basically anything besides a 9 and a 9. You could say 8 and a 7, whatever it is you want. Or you would have to find another numbers that you could multiply together that would give you 81. So you could take 81 and divide it by 5.6, and that doesn't give you a pretty number. It gives you 14.5. So 14.5 and 6. Any 2 numbers that you could multiply by 3, and it would give you 243 would also work. Skill practice, adding fractions. Remember when we add fractions? First, we want to go ahead and put them one on top of the other. And then we need to make sure we have common denominators. We don't have one. So 7 and 5, our common denominator would be 35. 7 times 5 is 35, so 2 times 5 is 10. 5 times 7 is 35, 4 times 7 is 28. So I have 10 35ths plus 28 35ths is 38 35ths. And this is called an improper fraction because the numerator is bigger than the denominator. So we find out how many times does this go into that. It goes once with a remainder of 3, and the denominator stays the same. So your answer should have been 1 and 3 35ths. On this one, simply 1/3 plus 2/3. Hopefully everybody knows that is 3/3 and that is 1 whole. Number 3, we have 1/4 plus 2/5. Again, we need to have a common denominator, which we're going to pick 20. 4 times 5 is 20, 1 times 5 is 5. 5 times 4 is 20, 2 times 4 is 8. So now I have 5 20ths plus 8 20ths, which is 13 20ths. Subtracting fractions. 2 and 4 11ths minus 1 and 4/5. I need a common denominator. An easy one is just 55. 11 times 5 is 55. 4 times 5 is 20. 5 times 11 is 55. 4 times 11 is 44. So I can't do 20 minus 44. So I have to borrow from my 2, make it a 1, and add 55 55ths. So I took a whole and I renamed it as 55 55ths because 55 55ths is a whole. And I chose this because my denominator is 5. So now I end up with 75 55ths. 75 minus 44 is 31. And I have 55 on the bottom. 1 minus 1 is 0, so your answer should just be 31 55ths. Number 2 is 4 and 3/4 minus 2 and 5/6. Again, I need a common denominator. I'm just going to pick 12. 4 times 3 is 12. 3 times 3 is 9. 6 times 2 is 12. 5 times 2 is 10. I can't do 9 12ths minus 10 12ths, so I borrow from the 4, make it a 3, and I'm going to add 12 12ths. I took away 1, renamed it as a 12 12ths because my denominator was a 12. So then I end up with 21 12ths minus 10 12ths, which is 11 12ths, and 3 minus 2 is 1. Please see me if you have any questions about this.